our graphs and our quadratics. You know how to find zeros with the graph itself. Again, we're just continuing on with our algebra and how do we find these things algebraically. So if I'm showing you the equation and the graph of y equals x squared minus 9, and I say, what are the zeros of the function? Then you're going to look at them and say, hey, the zeros of this function happen to be what? -3, 0. That's this guy right here. And +3, 0. So again, these are our zeros. We know zeros occur on the x-axis, otherwise known as your x-intercepts. You're going to impress all of your teachers later in life to be like, Keziah, you're going to remember that kind of good stuff. So now we can visually see them. Easy to find on a graphing calculator. But again, we want to be able to calculate them and find them algebraically as well. So what you would have done for me before, again, when I asked the question, what are the zeros? That means you're finding the x-intercepts. And we know that the x-intercepts occur if and only if the y value of each ordered pair is what? 0. So that's important. So for the past few days, you would have gone 0 equals x squared minus 9. And we would have used factoring, which is still a viable option. And I would have said to you, okay, first of all, we can't factor until we have a 0 on one side of the equal sign. Check. Next, make sure your equation's in standard form, meaning x squared comes first. Check. And then we would look at what's left and we'd ask ourselves, is this a short trinomial, a long trinomial, difference of squares, or a GCF? And your answer would have been difference of squares, which means that you were using square roots. Square root of x squared is x. The square root of 9 is 3. Not your answers. And you would have said, okay, so my two factors are x what? You got it. Set equal to 0, and then we would do what? Set each thing equal to 0. And we'd solve each equation. We'd subtract 3 from both sides. And I'd see one of my zeros is -3. Cool, that corresponds to this guy over here. I would add 3 to both sides. And I would see that x equals 3, which again, cool, corresponds to this guy. And hey, I have my zeros. So this method is one option. I'm going to show you another option today on how to solve this. Okay. So we're still going to use square roots. It's going to look a little different. So here's what we're going to do. So this is going to be the new way. The new option. So I'm going to take the same equation, the 0 equals x squared minus 9. Again, y got replaced with 0 because we're looking for x-intercepts. And our new option looks just a little differently. Instead of setting it equal to 0, my goal is to get x squared by itself. How can I get this x squared by itself? Add 9 to both sides. So I've got 9 equals x squared. And we know when we solve equations, our goal is always to get the x by itself. If x is being squared, what's the inverse operation that you learned yesterday to a square? A square root. So the opposite of squaring something is to square root it. When we were solving equations with addition and subtraction, notice we used the inverse operation. If we had plus, then the inverse was to subtract. We had subtract, our inverse was to add. So when we have a square, the inverse of a square is to square root. What we do to both sides of the equation is important, because if I square root one side, I have to square root the other side to keep the balance, just like I had to add the same number or subtract the same number to both sides. Now you know this. Square and square root, what happens to them? They cancel out, which is kind of cool, leaves me with x. What about the square root of 9? 3. Now, here's the small problem with our new option. Look at your answers that we found with factoring. Look at your answer that you found when you used a square root. What's the problem? Oh, we're missing the negative sign. We're missing the one that's the minus 3. And that's where the little bit of the problem comes in. Because if you do square roots, you have to know, you have to have memorized that even though you're only going to get one answer in your calculator when you do the square root of 9, there are technically 2. This answer and its opposite. So you need to make sure you include both. So there's our new twist for today. If we use our new option, we're going to get an answer, but you should always have 2 of them. One positive, one negative. And you will often see it written like this. X equals plus minus 3. That means that x is going to equal a positive 3, and x also equals a negative 3. So we're going to use that new terminology.